ugly, it's just dirty. Yeah, that's all. Nothing wrong with saying that. That's an objective fact. I have not seen
He went live last night with Post Malone Award, and he basically stood up and he moved his arms a little bit. Parker Porn, he got taken to Ozzy Osbourne's concert and they got canceled because he with
his health is not good.
no, his guitar guy.
Oh, really? I didn't hear about that.
Maybe. Oh.
All right. Today's going to be a wild and crazy day, so
I'm coming in after school to party with you.
sick.
Pinocchio.
Let's go. Go use the bathroom now. Go.
How'd you know?
I would do it every single day.
Alright.
Good to see you. Bathroom now. Go.
Yeah.
Whoa.
Wait a second. Remind me, I gotta come in tomorrow.
Go.
Wanna fight on him? Are you gonna do that? She gonna do deal?
You ready to rock and roll?
No.
Rock and roll. That's a song by Gary Glitter.
I don't want to rock and roll.
I really don't need to go to the bathroom.
Really? You want 5 minutes? What do you mean? All right. I'm not gonna be upset by that, right? Like, great. That's awesome. All right. Let's do this. Front two desks. Anybody gonna sit in them or no?
What?
Yeah, sit in them or no? Anybody? Okay, cool.
I got some home. Who farted?
You probably did.
I may carry around. Mr. Mack, you should know. The stapler's right here.
I'll go. That's it. And sit down. Review for a quiz.
Oh my gosh.
You. Anybody sitting back in these two desks? Make it quick. I'm not waiting for you to staple. Also, I would encourage you to not write stuff down once we get to the back pages. I'm warning you now. I am throwing a curveball on page 4. You need to pay attention, otherwise you will not hit the pitch. But it's fair because I'm tipping it. Okay? The reason I'm doing this is because
Oh, you have some sort of new disease. You are a new level.
we have one stapler the rest of the year. If it goes out, that's it. Too bad for you guys.
Yeah.
And I will demand staples or I will not grade it. That's right.
Where are you going with it?
Let's go!
Over here with it. Alright. Does that really affect you?
Well, if I put it away, I'll write on it. If it's out, I will like it too.
All right, page 4, throwing a curveball. Make sure you're paying attention. If you're not, you won't hit the pitch. It's fair because I'm tipping it, right? You need to make sure you're paying attention and not just writing stuff down. I would highly encourage you to, after page 2 especially, so 3, 4, and beyond, to not write anything so you can pay attention and get good to go. Again, throwing a curveball. You're going to have to think outside the box today. We have one class that was able to think outside the box and get past it. The rest did not, which is unfortunate. So we're doing it live. I hate this thing. I hate this thing so much. So much.
Not that bad.
Maybe if you're nice to it, it'll be nice to you.
All right, cool. All right, so here we go. Page 1 is translations. Translations are vectors. Remember, we're sliding everything by the same amount to the right and up, or to the left and down, or some combination therein. So this page isn't too bad, but I want to make sure you understand it before we go on. I'm going to skip number 1. I'm going to go on down to number 2, because number 1, as you can tell, is just a vertical vector sliding from B to B prime, meaning it's going in the downward direction, so don't say positive 8. Number 2. Where's the green that actually writes? Here it is. These 3 do.
You have like the same color green.
Because they're different size and so some I use for grading, some I don't, because the nicer ones are more expensive. That's right. So there's a vector taking c to c prime, and we know translations mean everything sliding by the same amount. So this vector, put it away because you need to pay attention. You have a quiz tomorrow. Stop bombing your quizzes and not paying attention in class. So same thing with b going to b prime and d going to d prime and a going to a prime. It's going to be the same vector for all of them. So pick a point, draw your vector, and then you can count what its components are. So it's going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. That means our rule is we're going to go 9 to the right, and I'll do that in blue. So plus 9, no you do not. And then we're going up 3 in the y direction from there. Again, the vertical component is this, and the horizontal component is this, and so there's our rule. Again, translations apply the same vector to every point. If we do that, we should know that our points are A. Let's look at A. Looks like it's negative 1, 2, 3, 4, 5, 6, 7, 8, I believe, to the left. That looks right. And then it looks like it's 1, 2, 3, 4, 5 down. Sorry that the lines are so hard to see. I did not update this document from last year. So 8 is negative 8, negative 5. You can't see what? You're good now?
There's a reflection on the screen for me.
Is there? Oh, this. I'm not sure why that is open.
You're watching the band kids practice outside.
I definitely not.
Gotta make sure the drummers are doing
Cool. So a prime, on the other hand, is negative 1, negative 2. And this checks out, because if you apply the rule, we add 9 to the x, and we get negative. Did I goof? It's positive 1. My bad. Thank you. So we get positive 1, and we get negative 5 plus 3 is negative 2. We cool on that. That's the idea of a translation. Same rule for all the things. There you go. Yeah, right? For b to b prime, c to c prime, they're all moving by the same amount. It's a slide, right? So every point moves by the same amount. Ready to move on?
Yes, sir.
All right, let's rock and roll. Page 2, we're doing reflections. These ones we get to eyeball. We don't need to find the perpendicular because the perpendicular is obvious. We don't have to do the midpoint because the midpoint is obvious. We can eyeball these. So we know that if I'm standing on one side of a mirror, mirror me is standing the same distance away from his mirror. So if I'm 5 feet away, mirror me will be 5 feet away. And if I move closer, mirror me will move closer. Same thing here. Here's me. I'm AB. There's our line of reflection. That's our mirror. So the distance from here to here, perpendicularly, right, will be the same on both sides. We have a distance of 5 here, which means we need a distance of 5 on this side. And that's where B prime will be. B prime. 1, 2, 3, 4, 5. So there's B prime. It's 5 away. Same thing with A. It's 5 away from the line of reflection, so it's going to be 5 away from the line of reflection when it flips. So there's A prime, and there's our reflection. Now, hi. Yep. Go ahead, Schlaffer. So A and B, we can write down their coordinates and then see how they change. We can figure out the rule that way, or we can be clever. Doesn't matter. Let's take a look. What kind of a flip are we doing here? Horizontal or vertical flip? Vertical flip. It's across a horizontal line, right? This line is horizontal, but we're flipping vertically. Exactly. So what's going to change, the x value or the y value? The y value, because y deals with vertical, right? Now, how did it change? Well, we went from up 5 to down 5, so we just negated it, right? We changed the sign.
Yes, sir.
We didn't change the x at all. And if you look at the coordinates, this plays out. So let's look at A. A's coordinates are negative 1, 5. And A prime's coordinates are also negative 1 in the left direction, right? Same x, but negative 5 down. That's the beauty about flipping across the x-axis. Not only is our line of reflection horizontal, which is nice because it's easy to find the perpendicular, et cetera, right? But it's also exactly on the x-axis, so it's really easy to just count and drop, right? Same x, different y. The sign changed. Remember, negation does not mean it makes it negative. In this case, it did because it means change the sign, and the sign was originally positive. We good?
Yes.
Awesome. If you notice for B, B is going to be 5, 5, and B prime is 5, negative 5. Again, checks out. The rule applies to both. Make sure it applies to both, otherwise you done goofed the rule, or you goofed up your coordinates. Very common mistake is to goof your coordinates. Let's look at number 5. What kind of a reflection is number 5? The line is vertical, but the reflection is horizontal. We're going from here to here. So that's across the y-axis. It's going to be nice and neat, nothing crazy like number 6 will be.
Will the vertical and horizontal flip, will we have to do that on the test tomorrow?
To write that, whether it's vertical or horizontal? No. We're just talking about how to figure this stuff out. Again, I'll tell you what it says. The directions say provide all coordinates in the rule for the given reflection. If it doesn't say in the directions, you don't need to provide it. So Number 5, it's a horizontal flip, which means we're going to flip in the x direction, which means we're going to have a negative x, positive y, meaning we change the x value and keep the y value when we flip. So, looking at C, it's 3 away from the line of reflection, which means it's going to be 3 away from the line of reflection when we're done. So there's C prime. B is 5 away, so it's going to be 5 away when we flip it, right? There's B prime. A is 5 away, so it's going to be 5 away when we flip it. There's A prime. And there's our triangle, right? Cool. Now we can write down those coordinates and see if they apply to the rule, or we can write down the coordinates first and then make the rule from that. We already made the rule, so let's check our rule. A, we said, was going to be at negative 5, 0. And A prime is at 5, 0. So what happened? Well, we kept the same y, and we changed the x. We did actually not negate the 0. We could have, and we wouldn't know, though, right? So let's try another coordinate. Let's try C so we can get a better idea. Zeros are weird, right? It's hard to tell what's going on in there. Did I negate the 0? Did I not? Right? Did I times it by something? Did I not? You can't really tell. So let's look at C that doesn't have any zeros. Negative 3, 2 is our coordinate for C. And after we flip it, we have positive 3, 2. So you can see what happened. The x changed, right? So what is here changes its sign. What's here did not. Now, did it become negative? No, it did not. Remember, a negative sign here is negation. It means to change the sign. Are we cool with that idea?
Yes.
Awesome. Are we good with 4 and 5? Do we see the logic here? Horizontal flip, vertical flip, all that stuff. When it's a vertical flip, we change the y value to a negative, right?
Is number 6 going to be on the...
Yes, it is. So here's number 6. Brace yourself. So let's talk about what this is. First of all, what kind of a flip is this? Horizontal or vertical? Horizontal. It's a vertical line, but we're flipping it horizontally, right? So the basic idea is we're going to change the x, right, to a negative. Now that's not going to work this time because this line is not our y-axis, right? It's not like number 5. It's a little bit different. No. Good idea, but not quite. So here's what's going to happen. Let's write down some coordinates and try to figure out what the rule is, see if you can eyeball it. If we look at A, when you count your coordinates, count from the origin. I bet a lot of you would have started here on this really thick line and counted over. Don't make that mistake. Start at the origin. It's negative 2, positive 1, 2, 3, 4, 5. So negative 2, 5 is A. Again, starting from the origin, count over and 1, 2, 3, 4, 1, 2, 3, 4, 5 for A prime, because that's where A prime will be, and I'll show you why in a second. Kind of skipped that step, my bad. I bet a lot of you counted from the line of reflection, didn't you? Raise your hand if you did. Okay, there's usually one in every class, even after I say it. Now, how do I know A prime is there? Well, I know A is 3 away from the line of reflection. So after I flip it, it's still going to be 3, which just so happens to put it right where D used to be. Now, this is a coincidence. Not all reflections map onto themselves, right? Here's an example. The red is the pre-image, the thing we're starting with. Here's A, B, C, D, the rectangle. After I flip B across the purple line of reflection, it's 2 away. It's still 2 away. Notice it didn't trade spots with C, right? Because it's only 2 away. C is 8 away from the line of reflection, so after I flip it, it's still 8 away. So on there, they traded spots because they're both 3 away from the line of reflection. They're going to switch, right? But here, not so. Do we see how this rotation works? Because that line of reflection doesn't cut this in half, it's not going to have them flip spots, right? It's just going to have them flip across the line. C ends up way over here, B ends up right there. We cool with that? Awesome. Now, just like A, D is 3 away, and when we switch spots, D is going to end up over here for D prime, right? Because it's 3 away here, it's going to be 3 away on the other side. So they do trade spots in this one. Let's write that down. D is at 4, 5, and when we flip it, it's at negative 2, 5. Now, the reason I'm writing both down is because if you just looked at A, you might think, oh, keep the y the same. Great. And then you'd say, oh, negative 2 going to 4. I add 6. Or maybe you'd think I multiply by negative 2. But if you look at D, does adding 6 get us negative 2? Does multiplying by negative 2 get us negative 2? No, so that rule doesn't work. This is more complicated. I gave you this as self-development last week, and I don't think anybody got it, or at least didn't get it yet. You can turn that in today if you want to get it. But here's the idea. What you're going to do is you're going to say, screw your line of reflection. Let's focus on mine. I'm going to flip it across the y-axis because I understand how that works. That's what this is, right? Easy peasy, no big deal. I'm going to negate the x, and that's going to get it done. Now, if we were to flip A across the y-axis, the purple line, sorry, pink, it would be 2 away, right? So it would be 2 away when I'm done. So I'd put A prime here. Now, that's obviously not the right A prime. The right A prime is over here. It's 2 away from where it should be. Look at D. If I were to flip it across the y-axis, the pink line, it's 4 away. So it would be 4 away on this side, which would put it right here. Now that's not the right d prime. The right d prime is the blue d prime. How far is it away? It's off by 2, right? So here's what we're doing. We're going to take our original point. We're going to flip it across the y-axis, not the line of reflection, but the pink line y-axis, right? And then we're going to move it to the right 2 to make up for our mistake. And the way we do that is we do what we did before and add 2, all the while never changing the y. And that's the rule. Why does it make sense? Because we're flipping it across the y-axis. That's what this means. And then we're going to slide it to the right 2 to put it back where it needs to go. So the way you're going to do this is probably not the way I showed you, right? What you're probably going to do is you're going to say, look, I know I'm supposed to flip it across the y-axis. That's what this is, right? A horizontal type of flip. And I know when I do that, I negate the x, keep the y. So I get this. This is our flip, right? We negate the x, keep the y. And then you're going to ask yourself, okay, now that I'm here, how do I get there? What do I have to do to this coordinate to make it look like that? Add 2 to the x. So I apply this vector to it, otherwise known as sliding it 2 to the right, and then I'm there. So all together, as one move, I negate it and add 2. How do I know to negate the x? Because it's a horizontal flip, just like the one above it, right? And then I know to add 2 because that's what it takes to get the job done. Now, does it work for d? If I take d and I negate it, I get -4, 5. Now that I have -4, 5, what do I need to do to make that a -2? Add 2. Same rule as before, right? So the rule is negate the x, add 2. It's a combination of things. A reflection over a weird line of reflection like this one is really a reflection over the y-axis and then a slide. It's one idea combined, right? It's kind of goofy, but that's what it is. Again, the way you need to look for this is you need to figure out, okay, horizontal flip, negate the y. Or I'm sorry, negate the x. Then you need to say, how do I get there? Well, in this case, it's add 2. So it's 2 things combined. Right, I mean, I might give you a horizontal one, or I might give you one that's slightly off, right? It's the same idea. The concepts are the same. How do we feel about that? That's kind of new. It's not really new. We did talk about this a little bit last week. Do we see that it's a horizontal reflection? Why do we negate the x for a horizontal reflection? Because x is horizontal, right? If we're 3 here, then we're going to be 3 there, right? One's going to be positive, one's going to be negative. So we change the sign. Why do we add 2? Because that's what it took to get the job done. In reality, it's what it took to match it up to where it actually needed to be. So again, we know we need to negate the x because we're flipping it horizontally, and then we add whatever we need to get it where it needs to go. Another quick example. Again, you're not writing any of this down. Here's coordinate plane. Here's the line of reflection. Here's the point I want to flip. A. Now I know A is 3 away from my line of reflection, so that means A prime is going to end up right here, 3 away from my line of reflection. We cool with that? Let's write those coordinates down. A's coordinates are negative from the origin, 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. A prime's coordinates, again, from the origin, don't go from here, from the origin, negative 3, 0. Cool? Now we know what kind of flip is this. What direction am I flipping in? Vertical flip. So what's going to be negated, the x or the y? The y. So I take this and I negate it. And what I get is negative 3, positive 6. That's our flip, right? Now that assumes a flip across this guy, which we are not, which is why we didn't end up in the right spot. Now what do I need to do to make that match up to this? I need to subtract 6. So my rule was I took x, y. I kept the x the same the whole time. I negated the y, which got me here. And then to get to there, I added 6, right? And there we go. We cool with that? That's the rule. How did I know to negate the y? Because I'm flipping vertically. Again, don't think about what direction this line's going. It's a horizontal line. Think about how we're flipping. We're flipping vertically. This was a positive 3 in this direction. Now it's a negative 3 across the line. So it's going to change the sign of the y value. How do you feel? Better is good. So, Andre, do we see it's a vertical flip?
I'm still looking at the one that we just did.
Okay, so going back. What kind of a flip are we doing, Andre?
Horizontal.
Horizontal flip. Which variable deals with the horizontal? X. So we're going to negate the X, just like we did for number 5, right? We did this kind of flip, we negated the X. The reason we called it a day there is because that's on the Y-axis. It's perfect, right? This one's slightly off the Y-axis. The Y-axis is the pink line. Okay? Don't worry about all the drawing here, okay? So see how it's slightly off the Y-axis? Okay, so it's not going to get the job done if we just negate it. Look at D. If we just negate it, we get this. And that's not what we got, right? So the question is, what do I need to do to make that match up? Well, I add 2, right? Well, look at A. If I just negate it, that doesn't get me what I need, right? I got to add 2. So the rule is negate it, then add 2.
And you just have to find the rule. You don't have to plot it.
You just need to find, well, you need to find the rule and plot it, I'll say on the exam. So the way we plot it is, look at this one. I knew A was here. See how it's 3 away from the line of reflection? It's going to be 3 away from the line of reflection, straight across. Always.
Yeah, but it's still the
What do you mean?
literally the same.
A and A prime?
No, for the on the other one for the reflection, it's like 3 and 3.
Which one are we looking at? Number 4, 5, or 6?
The bottom one.
Number 6? Okay, and which coordinates are we looking at?
So if you go on the line of reflection, if you like do D, you go over. Oh, we go on the word.
For the coordinates?
Yeah.
Yeah, coordinates are always from the origin. Does that make sense? Right, we always count from the origin?
I did that. I'm talking about when you have to graph it.
Right. So A prime, we said was 4, 5. How did we figure that out? Look at A. It's 3 away from our line of reflection, which means it's going to be 3 away from the line of reflection on the other side, which puts it here. Same spot as D used to be. That coordinate is 4, 5.
That's what it flips to.
Got it. And so now we're here, and now we have to figure out the rule. Negate the X, add 2.
Yeah, but then when you do the rest, the points just go besides this.
Are you weirded about it because they trade spots?
Yeah, that's what I'm saying.
That is a coincidence because both are 3 away from the Y-axis. Look over here.
That's what I was saying. 'cause
Yeah, look over here. Not always is that going to be the case, right? See how B's only 2 away from the line of reflection? It's still going to be 2 when you're done. See how it didn't trade spots with C? Right? That was just a coincidence
Okay.
before. That's 8 away, that's 8 away.
Yeah, that
Nice.
was-
Awesome.
Acknowledge.
Yeah.
I was wrong. I didn't do the math.
Okay, go.
Mush.
7. Rotation time. These are rotations about the origin. Again, the idea for all rotations, no matter where the dot is that we need to draw an L and move them, right? So let's do that. Starting at R, I'm going to draw my L connecting to B. I'll skip C and A for now. I'm just going to do this one point. So there's my L. From your perspective, R is pointing this way, the blue line, right? It's pointing to this way, to your left. If I turn that 180 degrees, it doesn't matter whether I go clockwise or counterclockwise, because if I go this way, I get here. If I go this way, I get here, right? That's why they don't specify clockwise or counterclockwise. So 180, we're starting this way. We turn 90 once, turn 90 again. Which way am I pointing now? To the right, the opposite direction. So I start here, my point of rotation, and I'm going to go 6, but I'm going to go to the right this time. 1, 2, 3, 4, 5, 6, because I took that line and I turned it 180 degrees this direction.
But if you turn it, so if it would be straight up, that'd be 90.
That'd be a 90 degree. Yeah, you see what I'm saying? 90, 90 again. Red is already pointing up. So if I turn it 90 degrees twice, otherwise known as 180, doesn't matter which way I go, right? 90 once, 90 again. Which way does it end up pointing? Down. So once again, the red is still attached to the end of the blue. The question was, is it going to point up or down? And we just figured out it goes down. It's the same length as it was before. And on the end of red is supposed to be B, right? So there's B prime. 3, the same as it was before. Let's write down those coordinates and try to figure out what the rule is. B is negative 1, 2, 3, 4, 5, 6, up 3. And B prime is positive 6, down 3. So looking at just those coordinates, what does it look like the rule was? We took our original X and Y and did what? We negated both, right? Now again, negate does not mean make negative. It means change the sign. So when we negate x, that negative 6 becomes positive, right? Negative times a negative is a positive. And 3 negated makes negative 3. Are you smelling what I'm stepping in? Why did we negate both? Well, it turns out whenever you put a dot in your quadrant, any quadrant, let's pick this one. If we do a 180-degree rotation about the origin, it's going to end up somewhere down here. Notice how the signs change for both. X changes, Y changes. We go from negative to positive and positive to negative. Now, if I chose a different starting point, like here, and I rotate 180 about the origin, I'd end up here. Notice how both signs change. Positive to negative, positive to negative. No matter where I start, both signs change. That's what this rule means. Yes?
Like, since you already have your B prime, is that, can you draw a hypotenuse from the B prime to the rotation?
You could. And so the idea is that this hypotenuse is kind of like a stick that both are attached to, and you're swinging them.
So doesn't that mean that at the corner, the right there would be your A prime? So it's right below the B.
The corner of that?
Or, yeah.
A prime would be like here,
Okay, I was thinking,
right? Because it's going to be a longer red part, but the same blue part.
I thought that was your already.
No. But again, that green part that he's talking about is basically like, I'm the point of rotation, the green part is my bar, and I'm swinging it around me, right? The length will always remain the same. Thank you, Dykema. So that's the rule for a 180-degree rotation. Let's look at 90-degree rotation. Let's look at number 9. Skipping number 8, on to number 9. From the origin, let's draw out to C. Here's our L. I tried to avoid B because B is both 3, 3, and I can't tell if numbers switch or whatever, right? I want different numbers, so I try to get an interesting looking L. I'm on number 9. So I'm going to draw this L and I'm going to rotate it. Pointing this way, pointing to my right, your left. If I rotate 90 degrees clockwise for you guys is this direction. So if I turn clockwise 90 degrees, which direction is that blue line going to point now? Up. So it's going to be 1, 2, 3, 4, 5, 6, 7 in length still, right? But it's going to point up. 1, 2, 3, 4, 5, 6, 7. Make 7 up yours. All right, so here's the red line. Red line's pointing up. If I turn 90 degrees clockwise for you guys is that way. It's now going to point right, which makes sense. We're swinging clockwise, so it's like that leg is swinging this way, clockwise. Yeah, it is kind of right. So now we're here, and that's where C prime is going to be. I would do all my points first, or at least 2 of them to really get an idea of the rule, but I'm going to tell you right now, C to C prime will be enough to figure out what's going on. So I'm going to write C's coordinate down. Looks like negative 1, 2, 3, 4, 5, 6, 7, right? Negative 7, 3. C prime is positive 7, 3, and I did 2 on accident. My bad. C prime should be there. My bad. Yeah, we negated the x, right? We changed x's sign. What was our x, which was negative 7, now becomes a positive version of that. So it's the same number, just different sign. Did the y change at all? No, it doesn't look like it, right? That's what it seems like to me. Where did I make the mistake? Oh, I definitely did. It's a mistake you're going to make. This is wrong. What?
Wouldn't it be 3, 7?
It is 3, 7. C prime is 3, 7, not 7, 3. What I did is I counted here 7, 3, and I wrote that down. You're going to do that because you're going to see this L, and it's going to be so intriguing. You'll be like, oh, yeah, follow that L. That's 7, 3, right? But here's the thing. Horizontal comes first. X, then Y. So it's 3, 7. So now what's the rule?
Y negative X.
So we flipped our X and our Y, didn't we? See how the 7 and 3 trade spots? So we have a Y and an X. Yes. Yes, I counted 7, 3, which is correct. But I want to know the coordinate. Don't X's come first? I have to go to the right, 3 and up 7. Yep, Don't just follow your L's. That's why I do this one next. All right, so we have Y and X switching spots, but not just switching spots. But see how this one was negative? And now it's positive and over here? So this guy got negated. What was our regular X became the opposite version when we flipped it. Again, look here. This is the one that changed. So you put the negative by him. They flip spots, yx, and then we negated this one because it changed its sign. Are we cool with that? All right. I will. So they traded spots, so yx. Okay. And then we negated this one because the -7 became a +7. So see how these, yeah, you see that? Change signs. Let's look at number 8 very quickly. 8 is the same rule, right? Because it's 90 degrees clockwise about r, just like 9. It's about the origin, so it's going to be the same dumb thing. It's going to be switch your x and your y and make it negative, right? Now let's check that. A and B are going to be weird because if you just draw to A, you're not going to make an L. You're just going to flip that, right?
Mr. Max.
What? You what?
They're both negated.
Not for this one. No, they're not.
For 8?
8. They're not both negated. So A would just be this little bar right here, not an L, right? And we'd flip that and it'd be over here, 4 in that direction. That's enough. I'll move on from that. Do we see how that works? Don't be freaked out when you don't draw an L. Sometimes you don't need an L. Going to C, we do need an L. Here it is. It's 6 in the blue direction, 2 in the red direction. We're pointing this direction for blue. I'm going to turn 90 degrees clockwise. That's this way for you guys. Which direction is that blue line going to point now? Sorry, I did it the opposite way, didn't I? Thank you. I didn't make the mistake on purpose. So if I go clockwise, for you guys, that's this direction. Which way is the blue line going to point? Down. So it's 6 in length going down. 1, 2, 3, 4, 5, 6. Red line, it's pointing down right now. If I turn 90 degrees clockwise for you guys is this way, it's going to point left. That is the test tomorrow. You are now. Wait till the next one. All right, C prime. Let's look at the coordinates. C is +6 down 2. And C prime is -6 down 2, right? So why is this not matching up with my rule? Because I followed the L again and I just got an L. That's what you're going to do tomorrow. Our coordinate is -2, -6. Do we see why that is? David, do we see why it is? Wonderful.
Get off the roll star.
Cool. He's doing fine.
Get off that idiot box.
He's doing great. Don't call David a box. All right.
Get off that idiot box.
I know. Questions on this page?
Get off of that idiot box.
All right. We're going to go on to a little bit more. It's not much more. Finding the rule is going to be weird. This is where I'm throwing a curveball. You need to be paying attention, which means if you're writing stuff down, stop doing it, because I'm going to make mistakes and I'm going to do it on purpose. Here we go. 10, 11, 12. It's rotations again, but we're doing it about an arbitrary point. So they give you the point. It's not the origin. Let's look at number 10. Rest in peace. Here we go. I'm going to go to B from the point of rotation.
Can you do this from any point?
Any point that's given. Yeah, any point that's given. Yep.
Okay.
So you can even do it from a point that's one of these. You could rotate about C and swing it around itself. All right, so here's our L. I'm going to rotate this 90 degrees counterclockwise. Now, counterclockwise is this direction, so I'm going to swing that way. So you can kind of already see which direction this is going to go. R is pointing this way, the blue line, so it's going to swing when we go counterclockwise for you guys is this direction. It's going to point down, correct? So the blue line's pointing down. It's 1, 2, 3, 4, 5 in length. 1, 2, 3, 4, 5. Red line pointing up. We're going to swing it counterclockwise. Counterclockwise for you guys is this direction, which means it's going to point to your left. So red line points left. It's 4 in length. 1, 2, 3, 4. B prime is where that is. So far, so good. Okay, let's write down B and B prime's coordinates and try to find the rule. This is where things get weird. We are not counting from here. We're counting from the origin. We're trying to find the coordinates, right? So it's -1, 2, 3, 4, 5, 6 to the left. And then 1, 2, 3 up, not 4. Again, we're counting from the origin. B prime. Looks like we're going from the origin. 1, 2, 3, 4, 5 to the left. And then we're going down 1, 2, 3, 4, 5 here. So far, so good. Why not? I made a mistake. What did I do? It's B prime. What's wrong with B prime? That's not the right coordinate. -5 from the origin. is fine. But then I went back. I wrote it down and I went back and I went and started counting from here because I thought, oh look, there's a line. I'll count from there. That's going to happen to you.
We didn't even catch it.
It's -5, -6 is what that is. That's not my only curveball. You better pay attention. Wake up.
So would it be?
What?
Y and then.
So, the rule, not as obvious, right? Switching them, negating them, adding, doesn't seem clear. And that's because we have this point here that's not on the origin. It changes everything, right?
Do another one.
So, what is the rule going to be? Here's how it works. The idea, if you remember from Friday, is that we're going to take our point and we're going to move it towards the origin. We're going to move it back to the origin, that way everything's good, right? Right? Totally fine. Now, remember from Friday, we couldn't decide whether it was move it towards the origin or move the origin towards it. Which one do you remember? We have debate, so we're going to try both. So moving it towards the origin, what do we do? What vector do we do to move that to there? 1, 1. So let's try it. We're going to take -6, 3, and we're going to apply our vector to it to move everything 1, 1. That's going to make our new coordinate -5, 4. So far, so good? All right. So I applied 1, 1 to that. It made it -5, 4. Then we have to rotate it. Now, what is a rotation counterclockwise 90 degrees? Well, think about it. If I have a dot here, and I go counterclockwise, that's this direction, yeah? Now I'm going to here to here. How did my signs change? X changed. The first one changed. So we have a -x. So a regular 90-degree counterclockwise rotation would have this as its rule if we were rotating about the origin. Okay? So we moved it to the origin. So in theory it should be now. And our rotation is going to be -x, y.
No.
Why not?
Because it doesn't match up.
Let's look at our clockwise rotation from the page before. What else did we do other than negation? We flipped them. Why did we flip them? Let's look at this. See this blue line right here? That's horizontal, right? So it's an X. When I rotate it, that same blue line is no longer an X, is it? It's vertical, so it's a Y. Do you see why they switch? What once was horizontal becomes vertical when we rotate 90 degrees. The X and the Y trade spots. So not only does the sign change, but X and Y trade spots. So our rule is going to be this. Sorry. It's going to be that. Comma. Cool? Yes, what's your question?
Did you get -5 for it? Because I've been trying to comprehend that.
I added 1 and 1 because I'm moving the vector 1, 1.
Oh, okay.
Cool. Better? Okay, awesome. Good question. No, thank you for asking. So now our next thing is we're going to flip them and negate them, right? So this is the thing that's been stumping every other class, and I think I'm going to present it in a different way. Hopefully it'll work better for you. Which do we do first? Do we flip them first or negate them first?
Flip.
Okay. So if I flip them, well, I mean, that's what it is when we do reciprocal, right? That's what it sounds good, right? So we do that. There's our flip, and then we negate it. So it's this. Okay. Now we're there. This is our 90-degree rotation, right? That step was all our 90-degree rotation. Although it was counterclockwise. I went the wrong way, right?
I feel like,
Nope, 180 is when we flip, when we negate both. We don't flip both. We don't flip both. We just negate both. Okay. So now we're here, and now we need to undo our previous vector to slide it back where it belongs, right? So now we're supposed to subtract 1, and we get 3, 4, which is not what we said we'd get. Oh God, we made a mistake. Where did we goof? Maybe we negate the 4 first and then flip them? Let's try that. Negate the 4 first, and we get this. And then we flip them. That's our rotation, right? That's counterclockwise. And then we're supposed to undo our vector. Boom. Got it. Okay. So order matters here. First of all, we did confirm that we're moving our point towards the origin, not the other way around. We're recentering all of our stuff to the origin. Does that make sense? Not the other way around. We're not bringing the origin to it. The origin stays put. So we move from there to there. That's a 1-to-1, right? Or 1-1 vector. Then we need to negate first and then flip. Negate first and then flip. negate first and then flip them. Does anybody know why that is? Why that has to be geometrically? I'll give you self-development points so you can figure it out. Why it works one way. Why it works this way and doesn't that way. Because like mathematically, it looks like, oh, well, what's the big deal, right? Right? Should work, but it doesn't. And again, if you look at it mathematically, it actually doesn't. But like, why doesn't that work geometrically? What are we doing in these steps over here that makes that not work if we do it this way?
It'd be more of like a vertical, like instead of like horizontal rotation. I don't know. I'm trying to process it.
You're like sort of maybe on the track, maybe. But yeah. I will give you self-development points if you can figure it out. Did everybody hear that? Everybody hear that? Did everybody hear that? Did everybody hear that? Did everyone hear that? May, did you hear that? Wonderful. Okay, so that's what we got to do. First, negate, then flip them for a 90-degree rotation, right? And then we undo our vector. How you feel? These? This is the only part of this quiz that's going to kick your butt. Okay? So that's the part you need to study. Make sure you got the other stuff down and then forget about it. Okay? No, literally. Right? And then do this. Translations, first page. Add and subtract, right? Reflections. Same distance on both sides. Okay? Rotation. Who cares? Okay? Rotations. Do your L's. To find the rule for a weird center of center of rotation, you need to first slide it back to the origin, then apply your rotation, whatever that is, right? Sometimes that means negate both, sometimes that means flip both and change one, right? You got to know what it means. And then undo your vector. Let's do another one. 11. First of all, what's the rule for a regular 180-degree rotation? Doesn't matter if it's counterclockwise or not, right? What's the regular rule for 180-degree rotation? We take x, y, and then what happens to them? Look over here. Here's a dot. 180 degrees can end up here, yeah? Both signs change. Now the question is, do we flip x and y?
Not first.
Do we do that or not? Look on the back page, 180-degree rotation number 7. Did we flip x and y? We did not. Why didn't we? Someone explain. The blue line is an x value because it's horizontal. And after I flip it, it's still an x value. That's why. Why am I telling you this? Because the last couple of questions on this exam, right, which are going to be self-development, ask you why it is and to explain it. We may or may not have time for me to write it all out, but I'm talking to you about it now. Re-watch the video if you want to get those self-development points. Not all of them, no, just the last three on the back. Okay, more or less. I'll talk to you about it in a second. So the x and the y don't switch for a 180-degree counterclockwise rotation. So let's look at B. B has an L that looks like this. When I rotate that 180 degrees, see that red part right there? It's pointing downward. When I rotate 180, it's going to point upward. So red goes up. 1, 2, 3, 4. And then the blue part, which is pointing this way for you guys, 180 degrees is going to point that way. Going to go left. So there's B prime. Now let's check these coordinates. B is at 1, 2, 3, 4, 5, 6, 7, 8. 8, 0. And B prime is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 4, 8. Now, again, our rule is supposed to be this, but we're not centered here, right? So what do we need to do to this to make this work out? We need to set it back to the origin. So we need to move everything by that vector. What's the vector that we're moving by? Looks like we're moving 1, 2, 3, 4, 5, 6 to the left, right? And 1, 2, 3, 4 down. So our vector is 6 to the left and 4 down. So we're going to apply that. What? 6 to the left and 4 down. So here's our B. We're going to apply that vector. 6 to the left and 4 down. That's going to make us here. Then, what do? Do we negate first or flip first? Well, in this case, it doesn't matter because we're just negating. We're not doing any flipping. Last time we did negate first, though, right? We changed that 4 to a -4, and then we flipped them. So we're going to negate them both. We get this. That's our rotation. Right? And then after that, we got to undo this vector. So we're going to add 6, add 4. When we add 6, we get this, and we get that. Boom. Done. So our rule is what? What did we do? Right? We applied negative x, negative y. But then we undid our vector, right? So we first did our vector. It's minus 6, minus 4. Then we negated them. And then what do? We added 6 and added 4 after we were done. That is the rule. The rule will be self-development, but that's the idea. Do you see how we did minus 6, minus 4 first? And that's why I did in parentheses. Are we cool with that? Then we negated both, because that's what this means, right? Our rotation, negate both. And then we added 6 and added 4 to undo what we did. And so that goes on the outside. So let me write that clearer. We took x and we subtracted 6 from it. We took y and we subtracted 4 from it. That was our vector. Then we negated both, right? And then we added 6 and added 4 to undo our vector.
Number 12 is
I don't like it.
Let's look at 12.
oh boy.
I'm drawing my L.
You're gonna draw an L for everybody.
Nope, not if you find the rule first. Then you can just write down the points and figure out where they go at using that.
Okay.
Now, I'm not going to give you a ton of these, right? You only have so much time. So I'm probably going to give you one of each, basically. So here we are. We're going to rotate 90 degrees clockwise. Clockwise is this way. That means B is going to end up here. And that's B prime. Let's write down these coordinates. B was originally at 1, 2, 3, it looks like. 3, 1. And then it's negative 1, 1 for B prime. So here's what we're doing. We need to move R back to the origin. That's going to move from here to here. That looks like left 1, down 3. So that's the vector we're going to apply. When we apply that, we get 2, negative 2. Now we need to apply 90 degrees clockwise. Look at 90 degrees clockwise. That's from here to here. Which one changes? The second one. We change it, and then we flip them. Luckily, they're the same. Then, we're going to undo what we did before. Why did we get the wrong answer? What do we do first? Previously, we changed 4 to negative 4, so we negated first and then we flipped. I negated.
Do you need to negate the vector, possibly?
Why do we get the wrong thing? Who sees it?
What?
You don't have to.
I feel like
There's too many twos.
I see that you added, you subtracted 3 from,
Mhm.
and then to get it from 3, 5 to 1, 3.
2 minus 1 is not, I'm sorry, 3 minus 1 is 2. 1 minus 3 is negative 2.
Yes.
That's wrong. What?
3 minus 1 is 2. 1 minus 3 is negative 2.
You didn't negate the other 2.
Why do I need to negate both of them? I'm
Because
going from here to here.
Yeah, if you negate it,
I want rice.
Remember, the rule is self-development. It's extra credit, basically. Okay? That's what we're working on right now.
So is it going to be on the quiz then?
It will be on the quiz, but it'll be as self-development if you want to do
If
it.
we get it wrong, it's whatever.
No penalty for getting it wrong.
I don't know.
Say it again. If you get negative.
You know, 1 minus 3 minus 1 is 2, 5 minus 3 is 2. I'm talking about the vectors. Like, you negate both of the vectors, or can you not do that?
I'm not sure what you mean by that. Are you talking about down here? 3 minus 1
I'm
is
talking about you negate the 1 and the 3 to get 2.
2. Can I negate the 1 and the 3? This right here? This one.
Yes. Can you negate those to make it go to 2, 2, and L?
To go backwards? Yeah, it goes backwards just the same as it went forwards, yes. You can, but you don't need to. Self-development for the rule. The rest of it is on you. Not definitions, but you need to, for those. Explain the rule for a 90-degree for clockwise rotation about the origin. You need to know 13. You need to know 14. You don't need to know 15. That's self-development.
I turned in most of the homework. When we get back, can I take the 5 and 6?
Will you be ready to do it and not make me grade it and have you fail it again?
Yeah, I'm gonna.
You're sure?
I'm gonna do the whole
Okay.
packet. I'm gonna watch the video.
Awesome. So if you come back and you really feel confident, then yes, I have no problem with that.
These.
I just don't want to waste your time.
Yeah,
you
these
know?
are the only 2 assignments that I didn't understand.
Sick. Okay, so we can talk about those.
Okay, that.
Right.
It's fine.
Cool, man.
Today I can't come.
That's fine. That's fine. That's fine. That's fine.
Mr. McAnally,
Appreciate the effort, man. Later.
I don't know. I don't think we should have to type a paper in here.
You shouldn't have what?
We shouldn't have to, I don't think we should type a paper. We should do something else.
Oh, really? Yeah, great idea. How about we just do a finalist where it's 2-letter grades instead of half?
Well.
Dude, I erased the curve equal to that somehow.
Wow, that's impressive.